Hi, everyone, and welcome to our webinar on the review of summer 2024. I'm Joe Delicarpini, the Science and Operations Officer here at the National Weather Service in Boston, hosting tonight's webinar. So, we'll start off with talking about what normal actually means. Remember that normals are simply 30-year averages, so they include all of the variations, say, over the summer that are part of our natural climate cycle. And our current normal period is from 1991 to 2020. These normals change every 10 years. Weather patterns, remember, they tend to occur in cycles, usually lasting several weeks at a time. And rainfall tends to be more localized during the summer, usually from showers and thunderstorms, as opposed to the larger coastal storms that we see during the colder months. So in summer 2024, this featured here in southern New England above normal temperatures, kind of near average precipitation. Some areas saw above, some were below. We'll show that in a couple of minutes. And there were a below average number of severe weather days, but several high impact events. This included several unusual large hail events. We typically don't see hail too much here in New England, as well as two EF1 tornadoes. So here's the summary for Boston and Worcester for the summer months. And remember, that's defined as June, July, and August. Boston featured above normal temperatures, as you can see on the left image, and below average precipitation, a little more than an inch below average. Out toward Worcester, temperatures were above normal, and precipitation was below average. You can see on the order of about 3.5 inches or so below average. Now, looking at Hartford on the left image, Hartford saw above normal temperatures as well, was kind of the theme for the summer, and below average precipitation, not by much, less than a quarter of an inch. And Providence saw above normal temperatures, but above average precipitation, you can see there by uh, almost 3.5 inches. And that was a result of the fact that a lot of showers and thunderstorms affected Rhode Island and adjacent areas of southeast Massachusetts over the summer. So that was kind of the jackpot for showers and thunderstorms over the summer. But if we look at it on a more regional scale, you'll see on the left, these are the accumulated rainfall totals. And you can see Western New England fared pretty well, some in those blue areas, looking for totals of about 15 to 20 inches, even in excess of 20 inches, of course, parts of Connecticut. The darker greens showing areas of 10 to 15 inches for the summer, and getting less as you go east toward the coast and eastern Massachusetts amounts under 10 inches, between 5 and 10 inches or so. This is actually a pretty normal pattern for the summer, with the higher amounts out in western New England and lower amounts as you head east. This is a result typically of thunderstorms weakening as they approach the coast due to the influence of the ocean, which tends to stabilize things quite a bit. Now, on the right, you can look at the comparison to those amounts to normal, and you can see much of western New England was above normal, especially Connecticut, even Rhode Island, where there was some much above normal areas here in the darker green. Kind of near normal across parts of New Hampshire down into central and southeast Massachusetts, with really just the coastal areas of eastern Massachusetts coming in below normal. And what we mean by that is about 50 to 75% of the rainfall that you would typically see in the summertime. Now, the number of 90-degree days is something we always get asked about. You can see here on the left, the average number of 90-degree days will be in the red bar, and the actual in 2024 is in the blue. So you can see Boston and Providence were just a little bit below their averages of 15 and 11, respectively. Hartford ended up with a well above normal number of 90-degree days at 27 compared to a normal of 17. And even Worcester came in just a little bit above normal with 5 90-degree days. Now, the highest temperature that was recorded over the summer at each of the sites was right around June 19th or 20th. That was our hottest day of the summer. 98 in Boston and Hartford, 93 in Providence, and 92 in Worcester. So the summer pattern, if we take a look at it, this is a composite on the left of our heights at about 18,000 feet, which in meteorology we call about 500 millibars. It's really where our weather patterns are steered from. And you can see overall pretty much a west to east flow across the northern tier of the United States. You can see a little bit of a dip here across the Great Lakes and Northeast, which tells us there was a bit of a weak trough. Nothing too unusual, but that tends to bring fast moving systems through cold fronts with showers and thunderstorms and that sort of thing. And on the right, this is kind of the departure from normal. And if we saw something unusual, we would see some deeper red or orange colors or even deeper blue or purple colors. But you can see this is pretty much an average pattern for the summer across much of the United States in general. So people always ask, how many warnings did you issue over the year, and was that really, above normal or below normal? And you can see here's a plot of all of our warnings going back actually to the late 1980s. You can see the averages here in black. It's just under 100. And for the 2024 season to date, we're looking at just over 105. So actually 113 was the actual number, and it falls a little bit above the average, but fairly concentrated with past seasons. So really nothing too unusual there. You can see certainly 2008 really stood out with a total of 290 warnings. That was a very active year. And on the flip side, 1987 only had 7 warnings. So typically we're somewhere in the realm of, say, 75 to 125. The average overall is about 92. If we look at flash flooding warnings issued, again, our average here is the black line, which is about 18. And for the 2024 season, we issued 21. So right in line with the average, maybe just a little bit above. And you can see certainly most of the years are clustered somewhere in that maybe 12 to 24 or so number of warnings per year, but certainly some active years. 2023 last year was one of our more active years at 73, actually the most active year. And 1998 and 2013 also come in line too, with roughly 61 of them in 2023. And back in 1998, there were also 61. The number of severe weather days is something interesting to look at too. And this is just the number of days, calendar days, that severe weather occurred. So you can see going back to 2004, there's been quite a variation. The average is about 24 days over the summer, roughly out of 90. And some of the lower years were 2004, there were only 9 days. Some of the more active years are well up into the 20s to near 30. In fact, 2020 featured 30, 2021 featured 34. And for this year in 2024, we featured about 18. So a little bit below average, but certainly not too far from it. So let's take a look here at some of the more significant severe weather events that we had. We started off in early May with a couple of significant hail days. These were pretty unusual for our area. May 8th featured quarter to golf ball sized hail, and May 9th, quarter to even tennis ball sized hail. That's 2-inch diameter hail, which can be very damaging. On the right, we can see the upper air map at 500 millibars. Again, this is about 18,000 feet, and you can see a bit of a trough or dip kind of swinging down over New England, but certainly this had a lot of cold air aloft with it. And early in the season, that can be very favorable for hail. At the surface, a weak low pressure system was moving through and really helped trigger those showers and thunderstorms. Was kind of a warm and humid air mass. So the combination of the heat and humidity down near the ground level and the very cold temperatures aloft really helped those hailstones form. And people always ask, how do hailstorms form? Why do they get so big? Well, here's a simple diagram that kind of shows you the process. And first, the raindrops kind of get sucked up into the storm's updraft. And remember, the updraft is the air that's coming into the storm and rising and eventually condensing into clouds and rainfall. So as these clouds form, the raindrops get sucked upward. Eventually, they reach the level where the temperature is at or below freezing. And once they reach there, they freeze and form into ice or hailstones. Now, these hailstones will grow and circulate in the updraft as long as the updraft can support them. But eventually, the hailstones get too large and they fall from the sky, and that's when the hail will fall down to the ground. So, in a nutshell, that's really our process. Raindrops get sucked into the storm, they freeze, circulate around the storm in the updrafts until they get too heavy and fall to the ground. So, moving on to the latter part of June, we had a pretty significant event. This was where our 2 EF1 tornadoes occurred. There was extensive wind damage across Connecticut, Rhode Island, and southeast Massachusetts. And our 2 EF1 tornadoes, one from Lincoln to North Attleboro and the other in Rehoboth, and those both occurred later in the evening. We'll talk about them in just a minute. The upper air pattern featured a pretty much trough moving through the eastern Great Lakes. This is a pretty typical summertime severe weather setup that we see, as well as a cold front moving through the area, which helped focus the showers and thunderstorms. Now, if we look at the radar loop, and again, this goes from 11 o'clock to midnight, you see a cluster of thunderstorms that moved out of Connecticut and western Massachusetts and really focused into Rhode Island and southeast Massachusetts, with the heaviest rainfall and actually where most of the damaging winds occurred as well. And there was a little bit of bowing along this line that helped a couple of tornadoes spin up very briefly. And we'll take a look at those a little bit more closely here. This was the first one from 11:23 to 11:30 is the radar loop. This was the EF1 tornado that touched down in Lincoln, Rhode Island, and moved into North Attleboro. You can see a little bit here in the reflectivity up on the top, a little bit of a notch and a closed circulation. And there is the circulation, in fact, as you see here, just north of Valley Falls. It's the red against the green. Here it goes. It tightens right up, moves across the border, and dissipates. A couple of other things that we look at, this is the normalized rotation, which really shows the red and purple at where that rotation is really being maximized before it kind of falls apart. And our differential reflectivity shows storm updrafts out ahead of the line, which indicated the storms were going to continue to make progress as they moved from Rhode Island into southeast Massachusetts. The other tornado was a bit shorter, only about a minute from 11:29 to 11:30, but from the same complex of storms. This was an EF1 tornado in Rehoboth. You don't see a lot in the reflectivity, just kind of a blob of heavier rainfall, but it certainly shows up very briefly here in the rotation as we go through. It's right there, and then lifts just as quickly as it goes. But you can see it in the normalized rotation, peaks very quickly right there, and then it dissipates almost as quickly. In this case, we did have a tornado debris signature. You can see right there. I'll let the loop go through again. You can see again green going down to the blue circle, which is coincident with our rotation, and that shows where debris is being lofted into the air. Keep in mind, this was very close to the radar, just several hundred feet above the ground, so it was very easy for our radar in Taunton to detect this circulation. Now, the storm environment on this day featured pretty good instability, strong jet stream level winds, and abundant moisture. And this is why the event was able to take place well into the evening when typically we would expect the storms to diminish. On the left is the instability aloft. Notice it's focused across the south coast, but there are some values of instability across southeast New England. At the same time, our jet stream in the order of 110, 120 miles per hour was lifting up through the eastern Great Lakes. And this area to the right is very favorable for a lot of upward motion or lift. So that helped the storm survive the trip. And as I mentioned, plenty of moisture. Our moisture axis along the south coast. So this is almost about 2 inches of moisture. These values are in millimeters that you see here. The storm environment, we really need to look in the lowest levels when we talk about tornadoes here in New England. And we did have sufficient instability on the upper left. Notice there's a little contour there. Low level shear, again, this is spin in the atmosphere, which helps the circulation spin up. And although the greatest values were offshore, there were values close to 100, which is what we look for, very close to southern New England. And on a local storm scale, it can even actually be higher. These are kind of on a broader scale that we're looking at here. On the lower left are lapse rates. That's the change of temperature with height, and we like to see values of 6 degrees or higher. In this case, we're closing in on 6.5. So that change of temperature with height allows those updrafts to really grow and be supportive of severe weather. And finally, on the right, this is our condensation level height. The lower, the better for tornado formation because we want that funnel to be able to reach the ground. In cases where the air is dry, it typically doesn't happen. But in these moist environments, the values are typically less than about 750 meters, roughly 2,000, 3,000 feet or lower. In this case, we were well within that. So we had all the ingredients there for a nighttime tornado in Rhode Island and southeast Massachusetts. Moving on into August, we had a fairly sizable event of wind damage and quarter to ping pong ball sized hail across eastern Massachusetts and Rhode Island as storms moved southward out of New Hampshire. Not something we always see during the summertime. Usually it's west to east, but you can see here a cluster of storms moving out of the Nashua, Manchester area down across the Merrimack Valley into greater Boston and eventually the South Shore before the storms dissipated, reaching Cape Cod. But this weather pattern showed similar to the first one in May that I showed, a closed low. This is reminiscent of some very cold air aloft coming down from Canada. Notice the flow in the wind barbs is from the north. So we're bringing in a lot colder air into New England, which is more supportive for hail. And the weather map that afternoon showed temperatures generally in the mid to upper 80s inland. Notice along the coast it was much cooler in the 70s. There was a sea breeze front across this area. And it was that sea breeze front that actually served as the focus for these storms to ride along as they came southward out of New Hampshire. You see, the weather map on the right really doesn't show very much, just high pressure over Pennsylvania. But we can draw on a line right here where the temperatures are a lot different. And that was our sea breeze front that helped focus the showers and thunderstorms. When we talk about hail, something we like to look at is the instability in that hail growth layer. So, the favored layer for hail growth is not a particular height, it's actually it has to do with temperature, and it's between the minus 10 Celsius to minus 30 Celsius layers. So, we look at the what's called hail cape or hail instability energy. There's a lot of that this afternoon across southeast Massachusetts, Rhode Island, and across areas of New Hampshire and Maine as well. So, these areas were definitely favorable for large hail as the storms move southward. And again, I'll talk about lapse rates. Again, how fast temperature cools with height. The higher the values, the cooler the temperature decreases with height, and the more updrafts can strengthen to support severe weather. If we take a snapshot of the radar as the storms are moving through metro Boston, you can see one storm in particular near Westwood, Norwood, and Walpole really pulsed up and produced a lot of large hail. You can see the storm updrafts are located just to the south, more toward East Walpole here on the radar image at Norwood. So that means the storms were favorable to continue moving southward and remain pretty strong. On the right, we have a couple of algorithms that we use. One is the probability of hail within the storm. This is the top right, and notice the values are in the pinks and even close to white, which is 80 to 100% probability of hail. And the radar can also estimate hail size, and notice in this case it's showing hail sizes of close to 2 inches or even a little bit more. Keep in mind, this is up at the layer where the radar is detecting the storm. So over this region, the radar is close to 1,000 feet. So on the way down, the hailstones are going to melt with temperatures in the mid 80s. So they're actually a little bit smaller. But up in the atmosphere, there was some pretty large hail going on, the size of tennis balls or even a little bit larger. So, in summary, for summer 2024, we featured above normal temperatures across the region. Probably not much of a surprise. Precipitation was near to above average, depending where you were. Western New England and portions of Rhode Island and southeast Massachusetts were above average from frequent showers and thunderstorms. Closer to average as you get out toward Worcester and central Massachusetts, and below average across much of the coast of eastern Massachusetts, from the Merrimack River, Newburyport, down through Boston to Cape Cod. And there were a below average number of severe weather days, but as we just talked about, several high impact events. This included several large hail events, most notably in May and in August, and two EF1 tornadoes at the end of June, which occurred during the evening. So I thank you for attending our webinar on the summer of 2024. As always, you can provide any feedback you like to me at the email address there. It's joseph.delicarpini@noaa.gov. And we'll be back with more webinars as we go through the fall. Our next will be a winter outlook, which will debut sometime in November. So look for that on YouTube, as well as a live announcement for the webinar on our webpage as well and social media. Thanks for listening.